Hi everyone, it's Miss Costa here, and in this video we're going to go through the EDEXCEL June 2017 paper 2. So to begin with, we're going to start with simplifying algebraic expressions. So when we're simplifying, you can almost think of like all of the letters, if they're being added and subtracted, as algebraic families. So everything that is the same letter to the same power can be brought together. So here we've got 5p, take 3p, plus p. So we can imagine that's 5 pairs. So we start with 5 pairs, we take away 3 pairs, so we're left with 2 pairs, and we add 1 pair. So that would be the same as saying 5 take 3 plus 1. 5 take 3 is 2, plus 1 is 3p. Next we've got simplify m cubed plus m cubed. So remember, if it's the same letter and the same power, we can just bring them together like terms. So that would become 2m cubed. People often get this confused because when we're multiplying things that have a power, we add the indices. But if we think about it, m would just be a length, so any old length. M squared would be an area, and m cubed would be a volume. So if I've got 2 lots of m cubed, I've got 2 lots of cubes that have a length of m. So that's why it's 2m cubed. Sometimes it helps if you draw them out as lengths and cubes if you have multiple powers. And then for the last thing, I've got 10 plus 3c plus 5d take 7c plus d. So this is where it's really helpful to circle all of the letters or all of the variables that have the same letter and the same power. So I'll leave the number 10 by itself. And then I've got positive 3c. Now a key thing is the positive or the negative sign always belongs to the term after it. So that's a really key point. So that's why I'd circled the plus. So I've got positive 3c and minus 7c. They're both in the same letter family. So 3 take 7 gives me minus 4c. So that's what they'd simplify to. And then I've got positive 5d plus d. So 5 plus 1. And also when it's just a letter on its own, it's like there's an invisible 1, because I don't say there's one leopard over there. I say there's a leopard. I don't need to always specify there is 1 if there's only 1. So imagine there's an invisible 1. So 5d, like 5 donkeys plus 1 donkey is 6 donkeys. So that would be positive 6. That's why I write a plus 6. And then I'm just left with the 10 over here. So 10 is at the beginning and everything else is happening after that. So 10 take 4c plus 60 is how I would simplify that. Next, I am rounding to one significant figure. So a significant figure is every non-zero digit before the number begins. So for instance, 0.000394, the first significant figure would be 3. But if you had 3.40009, the third significant figure would be 0. So 0 counts as a placeholder if it's in between 2 digits. But that's not relevant to this question, but just some extra knowledge there. So 56.78 to one significant figure means I circled the first digit, the first non-zero digit, which is 5. And I'm essentially saying, okay, that's 56. So what tens does that lie in between? So 50 and 60 would be what it lies in between. 55 is the halfway point, which is over here. And I know that 56.78 is going to be somewhere roughly over here. So 56 to one significant figure is closer to 60 than it is 50. But another way I can do that is I circle it, I look next door. If my number is 5 or more, so the next door neighbour, if it's 5 or more, I add 1 more to the circled digit. If it's 4 or less, I just ignore it and leave everything as it is. So just to show you what it would be if it was 54.78, I circle this, look next door, it's 4, so I ignore it and I round it down. So I turn everything to 0. So that would have been 50. But I add 1 more, so that becomes 60. and you can turn it into 60.00, but 60.00 is exactly the same as 60. So that's why I don't need to worry about that. Okay, so in this question, I'm dealing with a dual bar chart. And what that means is that there's two pieces of data that I'm looking at with every bar. So the key is very helpful to tell us what we're looking at. So let's read the question. It says, a teacher asked the students in year 6 what type of transport they use to get to school. And the dual bar chart shows the results. So I want to look at the key. And the key tells me that the dark grey bars represent the boys, and that the shaded diagonal bars represent the girls. So with a dual bar chart, you'll have your thing that they're talking about. In this case, it's transport as the x-axis, and the y-axis is always going to be the frequency, which essentially just means the amount. So the amount of people, in this case, students that go by car or walk. And it says, what is the most popular type of transport used by the boys? So that's important. It's the boys. So we're going to only look at the grey bar charts. And the most popular is really easy to find on a bar chart because it's literally the tallest bar, which represents the highest frequency. So this is the tallest grey bar. So therefore, I am going to say walking. The next question says 7 girls walk to school. Show this information on the dual bar chart. So walk is over here, 7 is over here. So I'm just going to draw a bar and shade it in like they have to represent the girls. The next question says, more of the students get to school by car than by bus. How many more? So what we can do is look over here. That is 5 boys go by car and 9 girls go by car. So in total, by car, 5 plus 9 is 14. So 14 people go by car. And then by bus, let's have a look. That's 6 people and 4 people. So 6 plus 4 gives me 10. So I need to find out how many more go. So I want to work out the difference. And to work out the difference, I always subtract. So 14 take 10 is 4. The next part says the number of students in year 5 is the same as the number of students in year 6. And just remember that I filled this out. So that over here was 7 girls. So what is the total number of students in year 5 and 6? So first I want to work out what the total number of students in year 6 is. So I know that that's 14 plus 10 because I've worked that out already. And then how many walk? Well, 9 boys and 7 girls. And 9 plus 7 is 16. And then I've got 4 and 1. 4 plus 1 is 5. And then I've got 2 and 1, which is 3. So if I add all those together, I can find out how many students are in year 6. So 14 plus 10 plus 16 plus 5 plus 3 is 48. So in year 6, there are 48 students, and therefore in year 5, there must also be 48 students because it says it's the same. So what is the total? Total means when I add everything together. So 48 plus 48 is 96. Okay, so here I've got an ordering fractions question, and this is a calculator paper, which is really handy because there's a really cool way that we can turn any fraction into a decimal. So with any fraction, this is the numerator, this is the denominator, and the line in the middle we call the divisor, which essentially means the way this would read, if I was reading it from like top to bottom, it means 2 divided by 5. So because we have a calculator, we can turn it easily into a decimal. To turn any fraction to a decimal, we just divide. So if I type into my calculator 2 divided by 5, that would give me 0.4. So let's write these all out. So that would be 0.4. 11 divided by 30. Oh, we could, sorry, I'm getting very ill. We could also do it another way, but I'm just going to show you the decimal way first. So 11 divided by 30 is 0.36 recurring. A half is 0.5, and 7 divided by 15 is 0.46 recurring. So what we could do is look at the decimals. The smallest decimal, if I ordered them, so that would be 0.4, and I just put 0 just so that I can compare them. 0.36 recurring, 0.50 and 0.46 recurring. I look in the first column because this is the largest place value, and 3 is the smallest digit. So 11 over 30 would be the smallest fraction. Then 4 is the next smallest digit. This and this both have 4, so I look at the hundredths column, and 0 is the smallest, so therefore 2/5 would be next. Then 0.46, which is 7/15, and then finally a half. So that's one way I could do it, by turning the fractions into decimals. Another way I could do it is all of these look like they have a very nice common denominator. So 2/5, 11 over 30, a half, and 7 over 15. All of these, if you're good at multiples, and you think to yourself, okay, what's the smallest, the lowest common multiple of all of these values? You'd realise that all of these multiply into 30. So what you could do is turn them into equivalent fractions. So if I've changed my denominator from 5 to 30, what have I multiplied 5 by to get to 30? I multiplied it by 6, so I'm going to have to multiply my numerator by 6 as well in order to keep the fraction equivalent. So that would be 12 out of 30. 11 over 30 stays the same because the denominator stays the same. And then what have I multiplied 2 by to get to 30? I've multiplied by 15. So I'm going to need to multiply 1 by 15 too, which is 15 over 30. And then similarly, what have I multiplied 15 by to get to 30? I've times by 2. So I'm going to need to multiply 7 by 2 as well, which is 14. So this makes it a little bit easier because I can see what has the smallest value. So this would be the smallest value. So 11 over 30 would be my first. 12 is next. Then 14. Oops, except 12 over 30 is 2/5. So always remember to write them as the original fractions that they've said. Then it would be 7 over 15. And then finally a half. So that's 2 different ways that you can order fractions. It totally depends on what you find easiest. If it was non-calculator, the best way would probably be turning them into equivalent fractions. But if you have a calculator and you're good with decimals and ordering them, then use that method. Okay, so here I've got a tally chart. I'm told that David sells CDs in a shop, and the tally chart shows information about the number of CDs that David sold on Monday, Tuesday and Wednesday. So a tally chart, when we do a tally, we essentially, for every one unit, we do a little line. So we go 1, 2, 3, 4, and when we get to 5, we cross it like that. So write down one thing that is wrong with the tally chart. Well, for Monday, that's 5, and that's 3. 5 plus 5 plus 3 is 13. Whereas he's written in the frequency 12. So on Monday, the frequency should be 12. He's just, should be 13. He's added it wrong. Next, we've got a pictogram where we represent a symbol. It represents a certain value. So a full circle represents 3 CDs. And David drew this pictogram to show the information for Tuesday and Wednesday. So on Tuesday, we got 3, 6, 9, 12, 15 CDs. But on Wednesday, we got 3, 6, And if this represents 3 CDs, then half of it would represent 1.5 CDs. So I would say the symbol chosen isn't accurate. You can't have half or 0.5 of a CD. So you can't go into a shop and say, hi, can I just chop that CD in half and only buy half of it? That's not how it works. So either he needs to change his symbol so that it represents 4 CDs, so that half of it could represent 2, or even so that it represents 2 CDs. But this would imply that he has sold 7.5 CDs, that each one of these represents 1.5 CDs. Okay, next, I'm told that there are 495 coins in a bottle. 1/3 of the coins are £1 coins. So the first thing I want to do is work out 1/3 of 495. And if I just try and visualize that, that means that 495 has been split into 3 equal parts, and I want 1/3 of that. So to work out 1/3, I would do 495 divided by 3, which is 165. So I know that there are 165 £1 coins. Next, I'm told that 124 of the coins are 50p coins. So there are 124 50p coins. And then the rest are 20p coins. So if I had 495 to begin with, and I know 165 of them are £1 and 124 are 50p coins, I can find out how much is left over by subtracting. So 495 take away 165, take away 124 is 206. So therefore, there are 206 20p coins. Now I need to work out the total value of the 495 coins. So let's have a go at doing that. So I know that there's 165 £1 coins. So 165 times by 1 gives me £165. Then I know that there's 124 50p coins. So if you want to turn it into money straight away, 50p is the same as £0.5. So I could do 124 times by 0.5. So 124 times by 0.5 gives me £62. And then for the last part, I've got 206 times by 20p. So 20p is £0.20. So I could do 206 times by 0.2, which is 206 times by 0.2 is £41.20. And total value means I add them all together. So in total, £41.20 plus 62 plus 165 gives me, so 165 plus 62 plus £41.20 is £268.20. I would say that's a good savings bottle. Okay, so the probability that a new fridge has a fault is 0.0015. I need to work out the probability that a new fridge does not have a fault. So with probability, there's either something can happen or it cannot happen. So I could wear a black dress today, or I could not wear a black dress today. I could cross the road today, I could not cross the road today. And with probability, the chance of something happening and the chance of something not happening has to add to 1. So the probability of something happening plus the probability of it not happening must add to 1. So the probability that a new fridge has a fault is 0.015. The probability that it does not have a fault plus 0.015 must add up to 1. Therefore, to work out the probability that it does not have a fault, I would need to do 1 take away 0.015, which would give me 1 take away 0.015 is 0.985. Next, I've got a list of numbers, and from the numbers in the list, I need to write down a square number. So this is where it's really, really handy to just know your square numbers off by heart. And if you don't, we're really quickly going to recap them. So the reason square numbers are called square numbers is because they form a square. So you've got 1 times 1, and that forms 1. Then you've got 2 squares times by 2 squares gives you 4. Then you've got 3 by 3, which gives you 9. I'll write underneath actually because it just gets a bit messy. Then similarly, you've got 1, 2, 3, 4 by 1, 2, 3, 4. So 4 squared is 16, and so forth. You can do it with all of the square numbers if you haven't quite remembered that. So it's helpful to just write them out. 1, 4, 9, 16, 25, 36, 49, just so that you have them there, so that it makes choosing from the list a little bit easier. And then from the list, write down a square number. Well, out of these numbers, 25 is a square number because I know that 5 times 5 makes 25. So my square number is going to be 25. I now need to write down a number that is a multiple of both 4 and 6. So I could start by writing out what the multiples of 4 are, which would just be the 4 times tables. So 4, 8, 12, 16, 20, 24, 28, 32, and do the same for 6. So I've got 6, 12, 18, 24, 30, 36. And which number is appears in both of these times tables, essentially. So when I get to 20, 24 appears in my 4 times tables and my 6 times tables. So that would be a number that is a multiple of both. 28 would only be a multiple of 4. So I wouldn't choose that because it needs to be a multiple of both. And write down all the prime numbers in a list. Now, prime number is a number that only has 2 factors. So it has 2 factors, 1 and itself. So essentially, the first few prime numbers are 2, 3, 5, 7, 11, 13. And if you can divide, apart from 2, 2 is the only even prime number. If you can divide it by 2, it's not going to be a prime number. So I can automatically cross out all of the even numbers. 2 is the only even prime number. So if it's divisible by 2, then it's not going to be even. Then I could try and think to myself, okay, are any of these divisible by 3? Well, 21 divided by 3 is 7. 27 is divisible by 3. Then I can try and think which of them are divisible by 5. So I'm literally crossing out all of the prime numbers. So 25 is divisible by 5. Any of these divisible by 7? Nope. 11? Nope. 13? Nope. So therefore, 23 and 29 would be the prime numbers that are in that list. So to eliminate anything that is not a prime number, first try dividing to see if it's divisible by 2, then 3, then 5, then 7, then 11, then 13. You've got a calculator, so that can help you speed things up. Next, we've got a angles question. So the key thing to know about here is this is like a little point. Okay, so all of these angles are around this little circle. And if I shrunk a circle so that it's tiny, 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 eventually it becomes a point, which is like a really, really small version of a circle. And angles in a circle or angles at a point sum to 360. So angles at a point sum to 360. So that's an angle fact that should spring to mind. Now, whenever we see this little symbol here, so 2 lines that look perpendicular, which means they cross at right angles, it indicates it's a right angle. And a right angle has a value always of 90 degrees. So I know that's 90 degrees. I don't know what this is, but I know that it's 3x and I know that this is 2x. Now I know that all three of these angles are going to need to sum, then need to add to 360. So I could say 2x plus 3x plus 90 must equal 360. So I'm forming an equation using the information I've been given. Then what I could do is just simplify it a bit. So 2x plus 3x, that would simplify to give me 5x. So 5x plus 90 must equal 360. Then to solve an equation, to move anything from one side of the equation to the other, I do the inverse operation, the opposite. So how could I get rid of 90? Well, if I took away 90, that would cancel it out. But whatever I do to one side of the equation, I have to do to the other. So I take 90 from this side as well. And I'm left with 5x equals 360 take away 90 is 270. So 5x equals 270. The last bit, when I've got a letter and a number next to each other in algebra, that means they're being multiplied. So x is being multiplied by 5. So to cancel, to get rid of that 5, I'm going to divide by 5 because any 5 divided by 5 is 1. So I have to divide this side by 5 as well. So I'd be left with 270 divided by 5 is 54 degrees. And that's my final answer. Okay, so in this question, I'm told that Suha is going to buy 150 envelopes and that here's some information about the cost of envelopes in 2 shops. So in letters to send, a pack of 25 envelopes you can buy for £3.49. And in Stationery World, you can buy a pack of 10 envelopes for £2.10. And if you buy 2 packs, you get 1 pack for free. So she wants to buy them as cheaply as possible. So I need to figure out which shop she should do that from. So 25 envelopes, I can do 150 divided by 25 to see how many packs of 25 she needs to buy. So 150 divided by 25 is 6. So she needs to buy 6 packs of 25, which cost £3.49. So if I just type that into my calculator, that tells me that she can buy them from letters to send for £20.94. So £20.94 from over here. Now, from Stationery World, she can buy a pack of 10 envelopes for £2.10, but if she buys 2 packs, she gets 1 pack free. So essentially, she can buy 30 envelopes for £4.20, because if she buys 30, she's essentially paying for 2 packs, and 2 packs would be 2 times £2.10, which is £4.20. So how many packs of 30 would she need to buy? Well, 150 divided by 30 is 5. So she would need to buy 5 of these, and 5 times by £4.20 is £21. So even though there's a nice deal where you get 2 packs and 1 pack free, it's cheaper to buy it from letters to send. So Suha should buy them from letters to send. And just make sure that you have all your working shown. Now for the next question here, I've got a conversion graph. So I can use this to convert something. So in this question, it would be centimeters to inches. So I need to change 74 centimeters to inches. So I find where 74 would be. So this would be 70 because it's halfway between 60 and 80. And then I know that there is 1, 2, 3, 4, 5 little squares in between 70 and 80. So between 80 and 70, that's a difference of 10 centimeters. So I do 10 divided by 5, which is 2. So each little square represents 2 centimeters. So 74 would be over here. So I draw a line from 74 across to my graph, and then I go down. And that takes me over here. So halfway is 25. And from 25 to 30, that's 5 squares. So each square is going to be 1. So that would be 29 inches. Now the next question, it says Daniel's height is 6 feet and 3 inches. and I know that 1 foot is 12 inches. So what is his height in centimetres? So let's first of all convert his height into inches. So if 1 foot is 12 inches, then 6 feet, what do I multiply 1 by to get to 6? I multiply it by 6, so I'd have to do the same over here. And 12 times by 6 is 72. So 6 foot, 3 inches would be 72 plus 3, which is 75 inches. So I need to figure out what 75 inches would be. Now there's a few ways that I can do this. Obviously the graph doesn't go up to 75, so I'm going to have to pick a factor of 75. So I could pick 25, because I know 25 times by 3 gives me 75. So I go across my graph to 25 inches, I go up to the line and across, and then that takes me to 64 centimetres. So 25 inches is 64 centimetres. So therefore 75 inches, what do I multiply 25 by to get to 75? I times it by 3, so I'd have to times this by 3 as well. And 64 times by 3 gives me 192 centimetres. So that's how I do that. Now the next question here, I need to find the value of whatever I type this into my calculator. So we could do this bit by bit just to make sure that we don't get anything wrong. So let's work out the numerator first. So I type in the square root of 13.4, take 1.5, and that gives me 3.449637662. And then I want to work out what 6.8, so I put in brackets 6.8 plus 0.06 gives me 6.86. So I'm just doing it bit by bit just to make sure. And then I can work out what 6.86 squared is by just doing answer squared, which is, so let's write all of it out. So 3.496376662 divided by 47.0596. So I can just type that into my calculator. 3.449637662 divided by answer is 0.7733035981. Now you can do it all in one go if you feel confident. So you press the fraction button on your calculator, you press the square root of 13.4, take 1.5, and then underneath you'd open your brackets and write 6.8 plus 0.06, close the brackets and write that to the power of 2, and you would get the same answer. So if you're confident using a calculator, do it that way. If not, do it bit by bit and then bring it all together. Next, I've got a rotation question. So I need to rotate shape A 90 degrees clockwise about the centre O. So O, the centre, is 0, 0. It's also sometimes referred to as the origin. And what you do is you place your tracing paper over the shape clockwise. If you think about a clock, so a clock starts with like 12, then it goes to 3 and then 6 and then 9. Clockwise is going in the direction of the clock. So what we would do is put our tracing paper above it and just shift it. So you'd mark a little point on all of your vertices and then you shift it to the right. And then once you've done that, you just draw down the vertices, write them down, and then you join the shape up. So this is done using tracing paper and your shape should look like this. Next, we need to describe fully the single transformation that maps triangle B onto triangle C. So we can see it's like a reflection. If you put a mirror down the line, you can see it's a reflection. And we need to think, where is the line of reflection? Well, here, if I put the mirror there, each point is exactly the same distance. So I would say it's a reflection in the y-axis. This line here is the y-axis, this line here is the x-axis. Next, I need to factorize. So factorize means pull out the largest factor and take it outside the bracket. So I know I'm going to put this into brackets. And I want to think to myself, what's the largest number that multiplies into 5 and minus 10? So 5 would be the largest number that multiplies into both of them. And then 5 times by what gives me 5, or 5 times by 1. And 5 times by what gives me 10, or negative 10, that would be minus 2m. And now the next part says factorize fully. So once again, I'm looking at the largest factor. So a way that we could do this is to try and write it all algebraically. So I know that 2a squared means 2 times a times b. And then 6ab squared, I'm trying to write it so that in terms of its factors, so the factors of 6 are 2 times 3 times by a times b. So then I can think, okay, what's common? Well, 2 is the largest number that's common, so that will go outside the bracket. Then I've got 1a in common, so that will go there. And then I've got 1b in common as well. So 2ab would be the largest factor that I can squeeze out and put outside the brackets. And then everything else I just leave. So here, 2ab multiplied by a would give me 2a squared b. And then what's remaining over here, I've got 3b. So that's how I do that. Now here I've got standard form, so write 4.7 times 10 to the power of minus 1 as an ordinary number. Just to recap, so 10 to the power of 1, 10 squared, 10 cubed. 10 to the power of 1 is just 10. 10 squared means 10 times 10, which is 100. 10 cubed is 1,000. So each time I'm going to a power of 10, I'm dividing by 10. Okay, so each time the power of 10 goes one power smaller, I'm dividing by 10. So 10 to the power of 0 would be 1, and 10 to the power of minus 1 is 0.1. So that's the same as saying 4.7 times by 0.1. And the quick shortcut way to do this is you think of your number, 4.7, and you know that you're multiplying by 10 to the power of minus 1. So you write 0.47 because it's minus 1, which means there needs to be 1 0 in front of your number before you start doing it. Or you could just write 4.7 times by 0.1 into your calculator, and that gives you the same thing, 0.47. Now next we've got work out the value of 2.4 times 10 cubed times by 9.5 times 10 to the power 5. So we could type this into our calculator all at once, or we could just do it bit by bit. So remember that 10 cubed, that means 1,000. So that's 2.4 times by 1,000, which would be 2,400. And 9.5 times 10 to the power 5, well, 10 to the power 4 would be 10,000. 10 to the power 5 would be 100,000. So 9.5 times by 10 to the power 5 would be 950,000. The shortcut way is think, okay, I start writing my digit 9, and then I need 5 digits after it because it's to the power 5. So 1, 2, 3, 4, 5. And that's how you do that. So I could type this into my calculator, 2,400 times by 950,000. And that gives me this number, 2,280,000,000. Now to write it in standard form is essentially a number times by 10 to the power of something. And this number needs to be between 1 and 9.9. So essentially it can only have one digit before the decimal point. So I'm going to write 2.28, okay, because only one digit can be in front of the decimal point. Everything else I put afterwards. And then I write it times 10 to the power of, and to figure out what that little power is, I can count how many digits are after that number I've put in the square. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And so on this map, it tells me that 1 centimetre represents 100 metres. Now I know that point T is 250 metres from point A. So 250 metres what have I multiplied 100 by to get to 250? To work that out, I could type in 250 divided by 100, which gives me 2.5. So I know that I've multiplied 100 by 2.5. So I'm going to have to do the same over here. So 250 meters is 2.5 centimeters. And I know that point T is 250 meters from point A. So what I do is I get my compass out on a ruler, I measure it, I put the pointy bit of the compass here and the pencil out to 2.5 centimeters, because then my compass is 2.5 centimeters at every point. I put the pointy bit of my compass over here, and then I just draw an arc that is 2.5 centimeters all the way around, okay? Because that means that point A could be on any of this point. So if you know that something is like, let's say 5 meters away from something, it could be in any direction. That's why we draw the circle. And then the next point, the next bit of information I'm told is that point T is equidistant from point B and C. Now, equidistant means exactly the same distance. So what I'm going to have to do is just draw a straight line connecting. Okay, so for the next part, I'm told that point T is equidistant from point B and C. Now, equidistant means it's exactly the same distance from B and C, and the way we can achieve that is by drawing something called the perpendicular bisector. And the way we do that is we just draw a line from B to C, and we open up our compass, put the pointy bit on B, and we open it up so it's roughly more than halfway, and we just draw a little arc, okay, on this side and on this side. And then we don't change the length of our compass at all. We put the pointy bit over here and we draw another arc, so there and there. And then we can join these two together, and that would form the perpendicular bisector of B and C. And I could carry that on. It doesn't look very straight because I don't have a ruler, but on your piece of paper you will. So that is the perpendicular bisector, which means this line is equidistant. It's the same distance from C as it is from B. So on the map, I need to show one of the possible positions for point T. So the only place that, well, one of the positions would be over here. The other would be over here where the line and the circle touch, but I only need to show one of the positions. So I would write that T, because the pink line shows me everywhere that is halfway between B and C, and the circle shows me everywhere that is 250 meters from point A. Okay, over here I've got a probability question. I'm told that the table shows the probabilities that a biased dice will land on 2, 3, 4, 5 and 6. Now biased means that it might be slightly heavier on one side, so that's more of a chance that it lands on that side. So I'm told that Neymar rolls the biased dice 200 times. Work out an estimate for the total number of times the dice will land on a 1 or a 3. So first of all, I know that probability always sums to 1. So the probability of it landing on a 1, 2, 3, 4, 5 or a 6 must all add to 1. So what I can do is add all these probabilities together. So if I add them all together, 0.17 plus 0.18 plus 0.09 plus 0.15 plus 0.1 is 0.69. So all of this adds to make 0.69, which means that if I take that away from 1, that will tell me what the probability of it landing on a 1 is. So 1 take away 0.69 is 0.31. So I've completed my probability table, and now I'm asked to work out an estimate for the total number of times the dice will land on a 1 or a 3. So what I need is the probability of it landing on a 1. So the probability it lands on a 1 is 0.31. The probability of it landing on a 3 is 0.18. And here is where the OR rule comes into play. And if you're essentially working out the probability of this or that happening, you add the probabilities together. So if in a pick and mix bag you had like those strawberry laces and those little candy mice and I don't know, jelly beans. The probability of getting a strawberry lace might be 5 out of 10. A candy mice might be 3 out of 10. But if you said what's the probability of getting a strawberry lace or a mouse, that would be 8 out of 10 because there's 5 laces and 3 mice. And you're saying this or that. So when we have to work out the probability of this or that happening, we add the probabilities together. So the probability of getting a 1 or a 3 is 0.31 plus 0.18, which is 0.49. And to work out an estimate of a probability, what we do is we do the probability of that happening times by the number of trials, which essentially means the number of times you try something out. So in this case, we know that they roll the dice 200 times. So the probability of getting a 1 or a 3 is 0.49, and I'm going to multiply that by 200. So if I type that into my calculator, that gives me 98. Okay, next I've got a mixed question. So on Saturday, some adults and some children were in a theatre. The ratio of the number of adults to the number of children was 5:2. Each person had a seat in the circle or had a seat in the stalls. Okay, so adults to children.
Okay, I found this on the web for Hey Adults.
Okay.
Check it out.
Right, so adults to children is 5:2. It says 3/4 of the children had seats in the stalls. Okay, so you either have circle or stalls, and I know that 117 children had seats in the circle. So 117 had seats in the circle, and I know that 3/4 of the children had seats in the stalls. So it's quite a tricky question because there's a lot that you need to extrapolate from here. But if 3/4 of the children had seats in the stalls, that must mean that 1/4 of the children had seats in the circle. So I know that 1/4 is equal to 117. So if 1/4, and again I can show this pictorially, if 1/4 is 117, then I know that 3/4 must be 3 times 117. So 3 times 117 gives me 351. So I know that in the stalls there are 351 children. So that's 351. There are exactly 2,600 seats in the theatre. On this Saturday, were there more people on more than 60% of the seats? So let's deal with that in a little bit. First of all, let's go with the information I've already been given, which is the ratio of adults to children is 5:2. So the total amount of children, if I do 117 plus 351, that's 468. So I know there are 468 children. So the ratio, I could draw this in parts to make it easier. So I know that adults to children is 5:2. So 1, 2, 3, 4, 5 parts to 2 parts. And I know that these 2 parts must make up 468. So what I can do is do 468 divided by 2 to figure out what 1 part is. So 234 is 1 part of my ratio. So that's 234. And that means that each part over here is also going to be 234. So if I've got 5 parts that are worth 234, I can do 5 times by 234 to work out the total amount of adults, which is 1,170. So now I've got some key pieces of information. I know in total there are 468 children and that there are 1,170 adults. So in total, how many people were there? Well, in total, I would do 468 plus 1,170, which gives me plus 468, 1,638. The question says that there are 2,600 seats, and I need to know if there were people on more than 60% of the seats. So I could write this as a percentage. To write anything as a percentage, you write the number. So there's 1,638 people out of the total, which is 2,600, and then I multiply it by 100. So 1,638 divided by 2,600 times by 100 is 63%. So I know there are people on 63% of the seats are occupied. So yes, because 63% is greater than 60%. Okay, so in this question, I'm given a trapezium. It's a prism. And the diagram shows a prism with a cross section in the shape of a trapezium. So this is the cross section here, the trapezium. And I need to, on the centimetre grid below, which means that each of these little squares represent a centimetre, I need to draw the front elevation. So they're always going to be nice and kind and show you that the front is from here. So essentially I need to draw this on the grid, and the side elevation, and the side elevation is here. So essentially what this would look like. So let's start with the front elevation. I know that I need to use a scale of 2 centimetres to 1 metre. So 2 centimetres equals 1 metre. And I know that the side is 2 metres by 2 metres. So therefore, what have I multiplied 1 by to get to 2? I've times by 2. I have to do to this side as well. So that means that my side is going to be 4 centimetres here and 4 centimetres here, and 0.5 metres. So I know that 1 metre is 2 centimetres. What do I, how do I get from 1 to 0.5? I divide by 2. So I'm going to have to divide this side by 2. So 2 centimetres is going to be, divided by 2 is 1 centimetre. So I know the height is going to be 1 centimetre. So let's draw 1, 2, 3, 4 as my side over here. And then 1, 2, 3, 4 as my side over here. And then I go up 1 centimetre, which is this part here. And then I can just join this with a straight line. So that would be 4 centimetres, 4 centimetres, 1 centimetre. And that is the front elevation. Now to do the side. So I've got a height. I've already figured out that this must be 1 centimetre. Now it's 1 metre, I know would be 2 centimetres because it's already here. So that'd be 2 centimetres over here. And up again 1 metre. Then there's this like little level, so I could just draw that here. And I know the total height up here, and the total height is 4, so I'm just going to draw a total height of 4 centimetres and join it up like that. So that's how I do it. It is quite hard to try and visualize, but if you just like think of a building or even a 3D object and how it just looks like straight dead on and straight from the side, you can't see all of the little angular bits, you just see it as a 2D shape, but elevations are quite tricky. Okay, next we've got a speed question. So Ollie drove 56 kilometres from Liverpool to Manchester. He then drove 61 kilometres from Manchester to Sheffield. So his average speed from Liverpool to Manchester was 70 kilometres per hour, and he took 75 minutes to drive from Manchester to Sheffield. So I need to work out his average speed for his total drive. So just a quick recap, to work out what speed is distance divided by time. If we ever forget it in the exam, you can think to yourself, what's the national speed limit? Well, it's 70 miles per hour. And what does the 70 represent? That represents the speed. What does miles represent? Well, miles is a form of distance. Per, what does that mean? It means divided by, so over. And hours is a measure of time. So that's just a quick way you might find it helpful to remember that formula. So let's look at how we can use that. Speed is distance divided by time. For the first part, I know he drove So if I have my formula, I know that his average, so for part 1 from Liverpool to Manchester, I know that his average speed is 70. So in this formula, speed equals distance divided by time. I can fill out the information I know. So I know that the speed is 70. The distance is 56. I just don't know what the time is. So I could rearrange this equation. When I need to rearrange it and the subject is my denominator, I can just swap them over, or I can do it bit by bit. So I could have said 70t equals 56, and therefore t equals 56 over 70. But either way, the time it took him would be 56 divided by 70, which is 0.8 hours. So I don't need to convert that into minutes yet, because when we're dealing with speed, distance, time, it's always best to use it in hours. So let's just write that key piece of information there. So from Liverpool to Manchester, I know that his speed is 56, distance is, his speed was 70, distance is 56, and the time it took him is 0.8 hours. Now I need to work out for part 2. So from Manchester to Sheffield, what do I know in my speed equals distance times time divided by time? So I know that it took him 75 minutes to drive. So this is where it gets a little bit trickier. So we always want to write our time in terms of hours. So 75 minutes, I want to convert into hours. So to do it, to convert minutes to hours, what I do is I divide by 60, because there's 60 minutes in an hour. So 75 divided by 60 is 5 over 4, which is 1.25 hours. So I know that, 1.25 hours. And I also know that the distance is 61. So the speed is going to be the distance, which is 61, divided by the time, which is 1.25. So his speed is 61 divided by 1.25, which is 48.8 kilometers per hour. So I've got all of this information, and now I need to work out, I'll just write it here. So that's Liverpool to Manchester, and then I've got Manchester to Sheffield, where the speed is 48.8 kilometers per hour. Distance is 61 kilometers, and the time is, what did I say, 75 divided by 60 is 1.25. So I need to work out his average speed, and to work out the average speed, it's not just work out the two speeds and then divide it by 2. To work out the average speed, you need to know the total distance divided by the total time. So the total distance is going to be 56 plus 61. So 56 plus 61 divided by the total time, which is 0.8 plus 1.25. So 56 plus 61 is 117, and 0.8 plus 1.25 is 2.05. So I just type that into my calculator. 117 divided by 2.05 gives me 57.0731, which I would round to, it doesn't tell me, but I would just probably round it to 1 decimal place. So 57.1 kilometers per hour. So this is quite a tricky question, just for 1 mark, but it's saying Janie drove from Barnsley to York and her average speed from Barnsley to Leeds was 80 kilometres per hour and her average speed from Leeds to York was 60 kilometres per hour. Now she says that the average speed from Barnsley to York can be found by working out the mean, which means adding 80 plus 60 together and dividing by 2. If Janie is correct, what does this tell you about the 2 parts of Janie's journey? Well, in order for her to be correct, and the reason we can't just work out the average speed by adding up the speeds together and dividing by 2 is because generally there's a different length of distance and a different length of time. So we need the total distance divided by the total time. So the only way that Janie could be correct is if the time taken for both journeys was the same. But it's quite an in-depth question to really understand it properly. Okay, so here we've got a similar shapes question, and essentially when we've got similar shapes, we have like a little shape A and then we have shape B, and they're similar because whatever one side of shape A is, let's say that's 2 and this is 6, it's enlarged by a scale factor to get me to the largest shape. So in this case, 2, if I multiplied that by 3, would give me the side of 6. So if I knew that this is 4, I could work out this side by using the same scale factor, which would be 12. So that's the premise that I used with similar shapes. So I know that ABC and EDC are straight lines and that EA is parallel to DB. Now, EC is 8.1 centimetres. So I know that this whole line here is 8.1 centimetres. DC, so this line here, is 5.4 centimetres. And that DB is 2.6 centimetres. Now, hopefully you can see that there's this little triangle here, which is 2.6 and 5.4, and that can be triangle DBC, and that sits inside this larger triangle, which has the length of 8.1, an unknown and an unknown. Now I need to work out the length of AE, which is this one here. So I can assume that these are similar shapes because they share this same angle, because both of them have this angle here. So they share this and they are on parallel lines and the shape is inside. So because they're on parallel lines, using corresponding angles, this angle and this angle would be the same. So they share 2 same angles there, therefore the third angle would be the same. So that's how I know that they're similar shapes. They haven't actually told me, so this is quite a tricky question to try and realise that. But let's see what we can do. So over here, I know that this side is 5.4, and I need to figure out what I need to multiply it by to get to 8.1. So to work out the scale factor of enlargement, I can do 8.1 divided by 5.4. So 8.1 divided by 5.4 is 3 over 2, which is 1.5. So I know that this shape here is 1.5 times larger than this triangle here. So to work out what this side here is, oh, why did it just delete everything? To work out what that side here is, I'm going to need to multiply its corresponding side by 1.5. So 2.6 times by 1.5 gives me 3.9. So the length of AE is 3.9 centimetres. Now, I'm then told that AC over here is 6.15 centimetres. So let's just get my 2 little triangles up again. It was 2.6 and 5.4. And then my bigger triangle was 8.1 and 3.9 and 6.15. So I need to work out the length of AB, which is just this length here. So what I'd first need to do is work out the length of BC, because that's part of this triangle here. So to get from the small triangle to the large one, I multiply by 1.5. So to do the opposite, I would need to divide by 1.5. So 6.15 divided by 1.5 is 4.1. So I know that this side of this triangle, this part here, is 4.1 centimetres. And if I know that this total length is 6.15, I could work out this little length AB by doing 6.15, take away 4.1. So 6.15, take away 4.1 is 2.05. Why is it just deleted? 2.05. Okay, so here I've got a compound interest question, and I'm told that Anna wants to invest £25,000 for 3 years in a bank. And which bank will give Anna the most interest at the end of 3 years? So if I go with personal bank, he invests 25,000, and to work out the multiplier, I think to myself, okay, so his original amount is worth 100%, and then it's 2% interest. So in total, that's 102%. Which, what does percentage mean? It means out of 100. So 102 over 100 as a multiplier would be 1.02. So that's my multiplier, and it's for 3 years. So either I can do 1.02 times by 1.02 times by 1.02, or I could just shorten that and do it times 1.02 to the power of 3. So if I type that into my calculator, 25,000 times by 1.02 to the power of 3, that gives me £26,530 and 20 pence. With the next bank, Secure Bank, I'm still investing £25,000, but for the first year, it's 4.3% interest, so I do 100 plus 4.3, which is 104.3%. Divide that by 100 is 1.043. So I times that by 1.043 for the first year, and then it's 0.9% for each extra year. So 100 plus 0.9 would be 100.9%. So 1.009 as a multiplier. So 1.009 to the power of 2, because it's 2 years, or I could write it as times 1.009 times by 1.009, and that gives me, so 25,000 times by 1.043 times by 1.009 squared is £26,546. I'm just going to round it to 46 pence. So which bank gives me the most interest? Well, if I subtract 25,000 from both of those, then the total interest for the first bank would be 26,530.2, take away 25,000 is £1,530 and 20 pence in interest, and from this bank it would be 26,546.46, take away 25,000, which is £1,546.46. So which bank will give him the most interest? Secure Bank. Okay, so here I've got an error interval question. I'm told that a number n is rounded to 2 decimal places and the result is 4.76. So if I write 4.76 here, and I think to 2 decimal places, what could it round up to? That would be 4.77. And what could have it rounded up from? That would have been 4.75. And I want to find the midpoint. So 4.755 is the lowest it could have been before it would have rounded down to 4.75. and 4.765 is the largest it could be before it would have rounded up to 4.77. So I'd say that 4.755 is less than n, which is less than or equal to 4.765. Oh, sorry, I got that the wrong way around. So 4.755 is less than or equal to n, because if it was 4.755, it would round up to 4.76, the 2 decimal places, and it has to be less than 4.765, because if it was actually 4.765, it would round up to 4.77. Here I've got a quadratic, and whenever I solve a quadratic, I need it to be equal to 0, which this is. And to solve a quadratic, what I want to do is factorise it. So I think of 2 numbers that would multiply to make -24 and add to make 5. So the factors of 24 would be 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So which of these combinations, and because they multiply to make -24, one has to be positive and one would have to be negative. So I could write x and x. And now which combination could allow me to get positive 5? So if I did 8, take away 3, 8 times -3 gives me -24, and 8 take 3 gives me 5. So that's how I'd factorise that. And then to solve it, what I do is I make each bracket equal to 0 one at a time. So x plus 8 equals 0. Therefore, if I subtract 8 from both sides, x equals -8. And if I made x minus 3 equals 0, and I added 3 to both sides, x would be 3. So my solutions would be x equals -8 and x equals 3. Next, I've got an arithmetic sequence, which means that each term has a common difference. So the first thing I want to do is just think to myself, okay, how do I get from 3 to 8? I add 5. How do I get from 8 to 13? I add 5. From 13 to 18, I add 5. And 5 is the common difference. So whatever your common difference is, that's what times tables the sequence is going up in. So I'd write 5n because it's the 5 times tables. And if it was the 5 times tables, then it would be 5, 10, 15, 20. But it's the 5 times tables, but it's been shifted. Each term is actually 2 less. How do you get from 5 to 3? You take 2. From 10 to 8, you take 2. From 15 to 13, you take 2. So the sequence rule would be 5n, take 2. Next, it says the nth term of a different sequence is 3n squared. And what does 3n squared mean? It means 3 times by n squared. Nathan says that the 4th term of this sequence is 144. Is Nathan right? So if it's the 4th term, n represents the position of the number in the sequence. So like the 1st term, 2nd term, 3rd term, 4th term. So the 4th term, n would be 4. So I do 3 times by 4 squared. 4 squared is 16. And 3 times 16 is 48. So no, Nathan is not correct.